Have you ever stopped to think about the unsung hero that powers our homes? I'm talking about transformers, those massive gray boxes you often see perched on utility poles or tucked away in electrical substations. They are the backbone of our electrical grid, tirelessly working to keep the power flowing. They might not be glamorous, but let me tell you, when a transformer goes down, it's not pretty. The impact is immediate and far-reaching. But why do they fail in the first place? And what's involved in getting the juice flowing again? The process is complex and requires skilled technicians, specialized equipment, and often a lot of time and effort. Let's dive in and find out. Subscribe, like, and comment if the video has made you learn something new. Transformers are built to last, but they're not invincible. These essential components of our electrical grid are designed to endure harsh conditions and heavy usage, but like all machinery, they have their limits. Just like any other piece of complex machinery, transformers can succumb to a variety of issues over time. Wear and tear, manufacturing defects, and external factors all play a role in their potential failure. One of the most common culprits behind transformer failure is overloading. This occurs when the transformer is forced to handle more electrical load than it was designed for, leading to excessive stress on its components. Imagine plugging a dozen appliances into a single outlet. The outlet would struggle to handle the load, and the same principle applies to transformers. When too many devices draw power simultaneously, the transformer can become overwhelmed. This scenario is particularly common during peak demand periods, such as scorching hot days when air conditioners are running non-stop. The increased demand for electricity can push transformers beyond their capacity. During these times, the excessive heat generated by the high electrical load can cause the transformer's internal components to overheat. This overheating can lead to insulation breakdown, short circuits, and ultimately, transformer failure. And it's not just heat that can do them in. Vandalism is another unfortunate reality that transformers face. Copper theft is a major problem, with thieves targeting transformers for their valuable copper windings. This not only causes significant damage but also creates dangerous situations for both the public and repair crews. Thieves often leave behind a dangerous and costly mess, requiring extensive repairs and posing risks of electrical hazards. The financial impact of such vandalism can be substantial, affecting utility companies and consumers alike. And let's not forget about Mother Nature. Severe weather events can wreak havoc on electrical infrastructure, including transformers. From lightning strikes that can cause sudden surges of electricity to heavy rains that bring down power lines and flood electrical equipment, the forces of nature are relentless. These natural events can lead to widespread power outages and significant damage to transformers, highlighting the need for robust and resilient electrical systems. But transformer failures aren't always dramatic explosions caused by natural disasters. Sometimes it's the slow, insidious creep of deterioration that brings them down. Think of it like rust eating away at a car. Insulation can break down over time, especially in harsh environments, leading to short circuits. Moisture can seep into the transformer's tank, contaminating the insulating oil and causing corrosion. Even seemingly minor issues like loose connections or faulty bushings can snowball into major problems if left unchecked. And then there are the illegal connections, those makeshift jury-rigged wires that bypass the meter and overload the system. These not only put a strain on the entire grid but can also damage transformers, putting everyone at risk. So, what happens when a transformer goes kaput? Well, it's not as simple as just slapping on a band-aid. These machines are intricate and vital components of our electrical infrastructure. Repairing these behemoths is a complex and time-consuming process that requires specialized knowledge, heavy equipment, and a whole lot of patience. Each step must be meticulously planned and executed to ensure safety and efficiency. It all starts with disconnecting the transformer from the grid and removing it from its location. Depending on the size and location, this can involve cranes, flatbed trucks, and a whole crew of linemen. The logistics of moving such a heavy piece of equipment are challenging and require precise coordination. This alone can take 3 days depending on location. Once the transformer is safely on the ground, it's transported to a repair facility where the real work begins. This facility is equipped with all the necessary tools and technology to handle the repair process. First, the transformer undergoes a thorough inspection to assess the extent of the damage. This initial assessment is crucial for determining the scope of the repair work needed. This is like a doctor giving a patient a checkup, except instead of stethoscopes, they use specialized tools to measure things like insulation resistance, oil quality, and winding integrity. These diagnostics help pinpoint the exact issues that need to be addressed. Inspection can take 1 to 2 days depending on damage. After the assessment, a detailed repair plan is formulated. This plan outlines the steps required to restore the transformer to its optimal condition, ensuring it can function reliably once reinstalled. The repair process may involve removing external parts including bushings, cooling fins, and the oil tank. The transformer core and windings are taken apart for further testing. If it was contaminated by water or carbon deposits, a deep cleaning process begins. This step takes 2 to 5 days depending on dirt and oil contamination. If the internal windings are damaged, they must be rewound completely. This involves carefully wrapping hundreds of meters of copper or aluminum wire, a highly skilled process. Burnt insulation and shorted components are replaced. Rewinding takes 3 to 7 days depending on the transformer size. Oil replacement and vacuum drying transformers use special insulating oil to prevent overheating. If oil was stolen or contaminated, fresh oil is added after vacuum drying the core. Vacuum drying removes moisture that could cause electrical faults. Oil processing takes 2 to 3 days depending on the transformer size. Reassembly and testing. Once repaired, the transformer is reassembled and tested under high voltage to ensure it's safe. This step alone takes 1 to 2 days because failures at this stage mean going back to step 4. Once the repairs are completed, the transformer undergoes rigorous testing to verify its functionality. These tests simulate real-world conditions to ensure the transformer can handle the demands of the power grid. If the transformer passes all tests, it's transported back to the site and reinstalled. Final checks ensure it's working before power is restored. This takes 1 to 3 days depending on accessibility. But the job isn't done yet. To prevent future failures, it's essential to address the root cause of the problem in the first place. This might involve upgrading the grid to handle increased demand, implementing measures to deter vandalism and copper theft, or simply educating the public about the importance of electrical safety. Transformer failures might be a fact of life, but they don't have to be a frequent occurrence. By understanding the causes of these failures and taking proactive steps to prevent them, we can keep the lights on, the refrigerators humming, and our communities connected. Whether it's reporting suspicious activity around electrical equipment, supporting efforts to strengthen the grid, or simply being mindful of our electricity usage, we all have a role to play in ensuring a reliable and resilient power supply. So the next time you see a transformer, remember the vital role it plays in our lives, and the hard work that goes into keeping them running smoothly. Now that you see the painful process of repairing a transformer, let's be real. Do you really want to go for 2 to 4 weeks without power because of something that could have been prevented? What you can do to protect transformers. Stop overloading. Don't connect extra houses or heavy appliances without approval. Report vandalism and suspicious activity. Thieves steal transformer oil, leaving you in darkness for weeks. Trim trees and maintain access. Vegetation can cause short circuits. Keep transformers clear. Say no to illegal connections. They weaken the transformer and cause it to fail faster. Cooperate during repairs. Blocking access only makes the blackout longer. Transformers don't fail on their own, many failures are preventable. Now that you know what's at stake, let's work together to protect them and ensure a steady power supply. If you found this video useful, give it a like, share it with your neighbors, and most importantly, subscribe for more eye-opening videos. Let's keep our power on.